All right, welcome to the third and final video of Module 6, where we're looking at Chapter 5, the skeletal system. So far, we went over videos that have talked about the basic structures of the skeletal system, so the bones, the ligaments, and the cartilage, specifics associated with those different structures. We've talked about how bones develop and form from fetal development all the way to adolescence. We talked about how bones can remodel and basically reform and structure themselves after they have matured. And then we talked about a brief overview of how the bone repair process happens whenever you have a fracture or a break. And so, what we're going to do in this final video is just talk about the different bones that are in the body and make sure that you're familiar with where they are and that you can identify them from any kind of model or image that you may see or get on, say, a quiz or an exam or your lab practical. Okay. All right. So the human body has 206 bones, and it can have, or each of these bones can be one of four types. They can be long bones, they can be short bones, they can be flat bones, or they can be irregular bones. An example of long bones would be like your limbs and your bones. So, for example, the tibia or the femur. Um, Short bones could be your wrist bones, so like your metatarsals. Flat bones are bones like your cranial bones, so the bones in your skull, your sternum, or your ribs. And then the irregular bones are just weirdly shaped bones, for example, like your coxal bone or your vertebra. Okay, and we'll look at all of these individually as we finish up this chapter. So, as we mentioned early on, the skeletal system has five specific functions: so support, protection, movement, mineral storage, and then the formation of blood cells. And so we're just going to look at all of the bones in the body and make sure you're familiar with where they're located and what part of the skeletal system they're associated with. So with the skeletal system, we can break it down into two different groupings. You have your axial skeleton and your appendicular skeleton. Your axial skeleton basically consists of the center axis or the central axis of the skeletal system. So it's the cranium, the vertebral column, and then the ribs and sternum. Okay, so all of the bones that are associated with that area. And then the appendicular skeleton is associated with all of the appendages and the girdles that attach those appendages to the axial skeleton. So, for example, the pelvic girdle is made up of um, for example, the coxal bone, and that coxal bone articulates with the femur, and it is associated with the legs. And then you also have, say, your clavicle and your scapula, which is articulated with your humerus, which is part of your arms. And so these bones are part of the appendicular skeleton. Okay? And we're going to break these down into their individual groupings, and we're going to talk about each bone that is found in each of these two groupings. Okay, so again, we have the axial skeleton, which is the midline or the axis of the body, the central axis. And then you have your appendicular skeleton, which are the bones of the appendages, and then the girdles that attach them to the axial skeleton. Okay. All right, so starting off, we're just going to focus on the axial skeleton first. We're going to look at the skull. We're going to talk about the cranial bones, the facial bones. We're going to show you the hyoid bone, which is an interesting bone because it does not articulate with any other bone, It's in your throat area, and it's actually where your tongue is attached, and your larynx and your pharynx. Okay. We'll then look at the vertebral column and the different regions of the vertebral column. And then we'll talk about the ribs and the sternum, and we'll talk about the difference between floating ribs and directly attached ribs. So first, we're just going to look at the cranial bones. So function of the cranial bones is specifically protection from protection of the brain. You have several different bones here. You have your frontal bone, your parietal bone, temporal, sphenoid, ethmoid, nasal, lacrimal, and occipital. And so the last part of this chapter is going to be a lot of memorization. So I would recommend maybe printing out pictures from the slides, maybe blanking out the labels and making your own worksheets and kind of going through the study with those because it is a lot of labeling and a lot of memorization. Okay. Not only does the skull have these cranial bones, it also has facial bones. Okay. And the facial bone is made up of the maxilla, the palatine, which is like the roof of the mouth, the vomer, which is associated with above the roof of the mouth, kind of in the back portion of the nasal area, your zygomatic bones, which are your cheek bones, and then your sinus cavities, which are the air spaces that are in these cranial and facial bones. And we'll show you an image of that here in a second. Okay. So here is the bones of the skull, so both the cranial and the facial bones. So in the back, you have the occipital. My laser pointer. On the top of the head, you have your parietal. The front of the head is the frontal bone. The back area, kind of above your ear, is the temporal bone. And that actually has articulation with what's known as the zygomatic bone, which makes up kind of the outer area of the eye orbital and the cheekbone. Okay. Behind the eye and kind of behind the zygomatic is the sphenoid bone. And the sphenoid bone, you see, kind of wraps down, right, and comes into contact with actually the palatine bone and runs beside the maxilla. The maxilla is the bone that holds the upper teeth. Okay. And then the mandible, which is our lower jaw, articulates with the temporal bone and holds the lower teeth. Now, inside of kind of the sinus cavity, so if you would kind of go in through this nasal area, down through this opening, you would see the vomer bone, which is also articulated with the sphenoid bone. Okay, so you have occipital, parietal, frontal, temporal, sphenoid, zygomatic. Okay, and then inside the orbital, the eye orbital, you have a lacrimal bone, which is this blue area, and you can see that little kind of hole there. That's where your tear duct is, and then behind that, in between the lacrimal and the sphenoid, is the ethmoid bone. Okay, you have your nasal bone, you have the maxilla, which is the purple, and then you have your mandible. Okay. And then if we flip the skull upside down, remove the mandible, this is what it looks like. So the occipital bone actually kind of wraps around and goes all the way underneath and articulates with the sphenoid bone. And the occipital has the opening that the spinal cord runs into the skull area in. And that opening is called the foramen magnum. And so again, you'll want to be able to label these if you saw them, or if you saw this image on, say, your quiz or your exam. Here you have the hyoid bone. And again, this is the only bone that doesn't articulate with another bone. And it serves as the attachment point for the larynx, the pharynx, and the tongue muscles. So moving down from the skull and following the axial skeleton, we come to the vertebral column. The vertebral column is there to protect the spinal cord, and it has 5 different regions that you need to be familiar with. The upper region, right below the skull, is the cervical region, which is the neck area. And this cervical region is made up of 7 vertebrae. Okay? After those first 7 vertebrae, you have your thoracic region, which is your chest region. And this region is made up of 12 vertebrae. And these 12 vertebrae are what the ribs are articulated with. Okay, so this is what holds those ribs. Underneath the thoracic region, you have your lumbar region, which is basically the small of the back. So where your back kind of curves in right above your butt. And this lumbar region is made up of 5 vertebrae. Okay? And then after that lumbar region, you have your sacral region and your coccygeal region, so the sacrum and the coccyx. And what's interesting with these 2 bones is that the sacrum is actually 5 fused vertebrae that make what looks like 1 bone, and the coccyx is 4 fused vertebrae. Okay, and so all of these 5 regions make up the vertebral column. And so you want to make sure you can identify and label these 5 different regions, and we'll show you those on the image in the next slide. And now in between each of the vertebra, you have intervertebral disc. And so those are those cartilaginous discs that cushion the vertebra, which also aid in movement and flexibility because those vertebrae aren't grinding against one another. So here you have your 5 regions. You have your first 7, which is the cervical region. The next 12 is the thoracic. The next 5 is the lumbar. And then you have your sacrum and your coccyx. Okay. And as I mentioned, these 12 here are the 12 vertebrae that your ribs are articulated with. And now we can also get issues with our vertebra, especially with our intervertebral disc, where you get what's called a herniated disc. So this is an image of healthy intervertebral discs that are in between each vertebra. You notice with this image here, the intervertebral discs are in place. They're not pushing against the spinal cord, which is shown here. But on this bottom image, you see a herniated disc, which is basically where that disc has ruptured and bulged out of its original shape and structure and is pressing on a nerve that radiates from, or that extends from, the spinal cord. And you can see that herniated disc pushing against that nerve that kind of runs down the vertebral area. And so this could lead to a lot of pain, a lot of discomfort. It can lead to like numbness in limbs, so like your arms or your legs, depending on where that intervertebral disc has herniated and specifically what nerve it's pressing on or against. Now, the other part of the axial skeleton is the rib and chest area. And so your ribs are there to protect your lungs and your heart. And then you have the sternum, which some of the ribs articulate with. Um, well, actually, most of the ribs articulate with the sternum via cartilaginous connections. Um, but there are two pairs of ribs that are floating ribs that don't articulate with the sternum. And the sternum is also there to protect the heart. And the sternum is what we basically refer to as the breastbone. Now, if we look at the ribs, there are 12 pairs of ribs, and they start at thoracic, the thoracic 1 vertebra, and end on the 12th vertebra in the thoracic region. Out of those 12 pairs, 10 are attached to the vertebra in the back and the sternum in the front. Out of those 10, the ribs can be directly connected or indirectly connected, but the key here is that they are connected to the sternum. The two lowest pairs, so pair 11 and pair 12, are what we call floating ribs. They are attached to the vertebra, but they're not attached to the sternum. Okay, so they're basically just kind of floating there. Okay? And so this image shows the articulation with those 12 pairs of ribs. So you have rib 1, so off thoracic 1, all the way down to rib 12, which is off of thoracic 12. Now you can see 1 through 10 has an attachment with the sternum via these cartilaginous connections. Now you can see 1 through 5 has this direct kind of attachment with the cartilage to the sternum. But 6, 7, 8, 9, and 10 kind of have this indirect attachment as they kind of all merge to one area and connect with the sternum. But then 11 and 12 have no attachment to the sternum. And so this one and this one is known as the floating ribs. Okay. And so that's it for the axial skeleton or axial skeletal structures. What we're now going to look at are the appendicular structures. So first we're going to look at the pectoral girdle and the upper limb, so the arms. So the pectoral girdle is just referring to the shoulder, which is made up of your clavicles, also known as the collarbone, and then your scapula, which are your shoulder blades. Okay? And then your arms, which are made up of the humerus, the radius, the ulna, your wrists, which are carpals, your hand, which is the metacarpals, and your fingers and your thumb, which are your phalanges. Okay, so here's an image of those bones. You have your pectoral girdle, so that collarbone, the clavicle, and then the scapula. Attached to that is the humerus, so the upper arm. And then you have your ulna, and then your radius. And the way I remember these two is I remember the radius is on the side of your thumb. The ulna is on the side of your pinky. Okay, so that's, you can just remember either or. Ulna is on your pinky side or radius is on your thumb side. And then you have your wrist bones, which are your carpals. Then you have your metacarpals, which is your hand. And then your phalanges, which are your finger bones. Okay, so that's identical on both sides, so both arms, left and right arm. And then when we move down to the other part of the appendicular skeleton, we look at the pelvic girdle and the lower limbs, so the legs. So the pelvic girdle is just referring to the hip. So you have your coxal bones, two of those, your sacrum, and then your pubic symphysis. And the pubic symphysis is this cartilaginous region that is between the front portion of the two coxal bones, and we'll show you that in the next slide in the image. But it's just kind of this cartilaginous connection. When we look at the bones in the legs, you have your femur, which is your upper leg, the patella, which is your kneecap. Then the lower leg is made up of the tibia and the fibula. So the tibia is the bigger bone. The fibula is the bone that's the smaller one that kind of runs down and makes your ankle. the little kind of bump, the little bony kind of structure off the side of your ankle. But the ankle itself is made up of the tarsal bones. You have your foot, which is the metatarsals, and then you have your toes, which are phalanges, which are exactly the same name as the phalanges in your fingers. Okay, so here we have a figure with that. So you have your pelvic girdle, so your coxal bone, so you have one, you have two, you have the sacrum, and then this cartilaginous connection that connects kind of the front portion of the coxal bones is the pubic symphysis. So those coxal bones articulate with the femur. Then you have your kneecap, which is the patella. You have your tibia, you have your fibula, and this is what I was saying, that little kind of ball structure on the outside of your ankle, that's actually your fibula. Right. Then you have your tarsals, which is your ankle itself. Then you have your metatarsals, which is your foot bone, and then your toes, which are phalanges. Okay. And now, what's interesting with the pelvic girdle, you actually can determine gender based off of the size and shape of a pelvic girdle. So the pelvic girdle in women is actually broader, shallower, and it has a wider opening compared to males. And this is because females have to pass a embryo fetus, a baby, out of that pelvic girdle during birth. And so that pelvic girdle has to be set up so that baby delivery can happen. And so you actually can identify gender based off of the steepness and the opening of that pelvic girdle. Okay. And so we were going to look at joints for kind of our last portion of this chapter, where these are the connections between the bones. Okay? And so there are three different types of joints that we can have in the skeletal system. You can have a fibrous joint, cartilaginous joint, or a synovial joint. Your fibrous joints are these immovable joints, so they don't really move. And we have fibrous joints between the bones of our skull. And so, for example, if you've ever been around an infant or a baby, you know that they have this soft spot on the front portion of their skull on top. So where the frontal bone and the parietal bone would meet. That soft spot is there because the bones in the skull haven't finished growing yet, and they haven't fused together. And that's because the bones of the skull need to be flexible so that the baby's head can actually go out through the birth canal. If those fibrous joints weren't there, then it would be very difficult for the head of the baby to make it out of the birth canal. And I actually have an image in the next slide just kind of showing what those fibrous joints look like in a fetus. The next type of joint is a cartilaginous joint. So this is somewhat movable, has cartilage connections, and an example of that is adjacent vertebra. And so you know your vertebral column is flexible, it's movable, but it's nowhere near as movable as the joints in your elbows, your knees, your hips, or your shoulders. Okay, those joints are known as synovial joints. They are really freely movable. The bones are separated by this fluid-filled cavity. There's different types of cartilage that is kind of around the ends of the bones and in between the bones. It's allowing for friction to not happen and to make sure that the ends of those bones and those joints are protected and they're not damaged whenever that movement happens. So here's an image of the fibrous joints, and you can see you have your frontal bone, you have your parietal bone, and you have the fibrous joints between those. So the parietal bone's not fused together, the frontal bone's not fused together, and then those two aren't fused to each other. Even the parietal and the occipital bone is not completely fused together. And so this area here is the soft spot in the baby's head. And again, the joints are not fused because the baby's head needs to be somewhat flexible as it goes passes through the birth canal during birth. Now, for synovial joints, we mentioned that these joints are the freely movable joints, and that there's this fluid-filled space in the joints. And in this kind of joint capsule, and say your knees and your elbows, for example, you have a synovial membrane and the haline cartilage that we mentioned in the very first video for this chapter. Now, that synovial membrane, it secretes what's known as synovial fluid, and this fluid serves as a lubricant to make sure that there's no friction as those bones kind of glide across the cartilage as you move, say, your elbow, and so it makes sure no friction happens. And then that haline cartilage is there to serve as a cushion, so that, say, like when you jump up and down, your tibia is not slamming into the end of your femur, causing damage. Right? And so you have your haline cartilage and your synovial membrane kind of working together to make sure there's no friction and that the bones have this cushioning to prevent damage during movement. There are two types of synovial joints. You have a hinge joint, which is your knees and your elbows, and you have a ball and socket joint, which is your shoulders and your hips. And so we've mentioned tendons briefly, but we haven't really put it in text form in the slide, actually. But so tendons join bone to muscle. And we'll show this here in the slide here. And so, for example, your thigh muscles are joined via a tendon, for example, to the patella, whereas a ligament is joining bone to bone. So you see here, for example, you have your anterior ligament, which is connecting the top of the tibia to the lower end of the femur. And then you can see kind of this blue cartilage here, which is the haline cartilage. And you have your meniscus right here. And so, for example, you have your PCL, your ACL, and then you have the ligament that's connecting your patella, and then the cartilage that's underneath the patella, right? And then this purple area, here's the joint capsule that's surrounding this area, so the lower end of the femur, and that is allowing that fluid to be in the space so that it lubricates the femur connection to that meniscus. Okay. And so again, we've mentioned ligaments attaching bone to bone. So for example, in the synovial joint, an example of that we just showed, which is the ACLs, which is the anterior cruciate ligament. Tendons attach muscle to bone. An example of that is the Achilles tendon. And like I mentioned at the kind of the first video, tendons and ligaments are dense fibrous connective tissue that contains collagen as well as connective tissue, so that those the tendons and the ligaments are strong, but they're also flexible to allow movement. And then we also have muscles that are attached to the bones that stabilize the joints, that causes forces to actually kind of work with or against the movement to help keep upright posture, or to allow us to flex or extend our arms or our legs. And so all of those work together to make sure that movements happen within the body. And the different types of movements that you can have are, so for example, abduction, which is moving a limb away from the body's midline. So in this example, we're moving, so let's say you have your midline, you're moving away. Adduction is when you're moving towards your midline, so going down. Extension is when you increase the angle. So here you would have an angle of 180 degrees. Flexion is when you decrease the angle. So this is less than 90 degrees, right? And then we have two other types of movement, so rotation and circumduction. The way you can think about this is rotation is if you rotate it around an axis. So for example, if you hold your arm straight out and you just kind of, move your arm kind of on the same plane, but you're just kind of rotating your wrist. Okay, so that's rotation. Circumduction is like in gym class when you did arm circles. And so you're moving your arm in kind of that big cone movement. And so that's the difference between circumduction and rotation. And so for the last couple of slides, we're just going to mention just some diseases and disorders of the skeletal system. So you can get sprains, which are just stretched or torn ligaments. They take a long time to heal because ligaments, they don't have a lot of blood. They don't have a good blood supply. And so, poor blood supply means a long time to heal. And so that's why sprains can kind of take a few weeks to get better. You have what's also known as bursitis or tendonitis. This is whenever you get inflammation in your tendons. Arthritis is inflammation in your joints. And then we've already mentioned osteoporosis, which is where you have excessive bone loss. And so again, that's an abnormality in the balance of your osteoblast versus your osteoclast. And so here's an image of, say, a normal bone. And so pay attention to the lattice work here compared to, that spongy bone inside of a bone with osteoporosis. You notice there's holes in that structure, looks a lot more brittle, and you can see, especially like right in there and there, here too, why those bones are so much easier to break. And over time, it also can lead to pain, difficulties in movement, bad posture, and can really become a hindrance to individuals as they get older, and can really be kind of like a big issue for people to live with. All right, and so that does it for chapter 5. And so that's all the information you need to look at for this chapter and module 6. As always, let me know if you have any questions, if you have any concerns, and we will see you in the next module.